The Russ Prize is the premier prize in bioengineering. It was originally awarded in the year 2001 and is awarded every other year. It's awarded by the National Academy of Engineering in cooperation with Ohio University. Fritz was one of the original entrepreneurs after World War II in the electronics industry. He and his wife Dolores formed their company in the early 1950s. They dug the foundation for their original building themselves. When they sold the company in 1987, it was one of the largest engineering consulting firms in the country. They lived modestly, even though they were very wealthy people at the end of their lives. They started the award because Fritz was always concerned that the Nobel Prize was not awarded in engineering. He conceived the Russ Prize to fill that gap. The type of person that would win the Russ Prize is someone who would take a basic scientific concept, apply engineering principles, and solve a practical problem. That practical problem, in the case of the Russ Prize, would have significant impact, be in widespread use, and improve the human condition. Fritz was known for thinking 20 or 30 years into the future. In fact, I would say that his impact on Ohio University itself is to inspire us and to set the example for long-term visionary thinking. Examples of past winners of the Russ Prize have included the inventors of the implantable heart pacemaker, the inventor of kidney dialysis, the inventor of the automated DNA sequencer, and the inventor of the enabling technology for heart-lung machines. The Russes wanted to ensure in perpetuity that achievements such as these continued to be awarded, and thereby inspiring a new generation of engineers.
The 2015 Fritz J and Dolores H Russ Prize is awarded to Blake Wilson, Graeme Clark, Erwin Hochmair, Ingeborg Hochmair-Desoyer, and Michael Merzenich for engineering cochlear implants that enable the deaf to hear. Michael M. Merzenich, a neuroscientist and professor of otolaryngology at the University of California at San Francisco, established some of the neurophysiological foundations of present cochlear implant, or CI, designs in 1971. Best known for his groundbreaking discoveries in multi-site stimulation of CIs and neuroplasticity, he, along with other CI contributors, developed the Advanced Bionics Cochlear Prostheses, which enabled greater access to and commercialization of CIs. Electrical engineers Erwin Hochmair and Ingeborg J. Hochmair-Desoyer began their work on CIs as a team in the mid-1970s in Austria. Building on existing knowledge of the physiology of the auditory system, their engineering-based approach led to the world's first microelectronic multi-channel CI, which is considered to be the prototype of today's modern CIs. The first two devices were implanted in 1977 and 1978. The Hochmairs have continued to develop cutting-edge hearing implant technologies through their company, Med-L. Meanwhile, in the 1970s in Australia, professor and physician Graeme Clark was independently studying multi-site stimulation of the cochlea by routing particular speech sounds to its various parts. He was focused on designing an implant that would sit flawlessly against the cochlea to correctly stimulate nerve endings. Clark's design was perfected in 1978, and not long after, he implanted his CI into a patient. Clark went on to help create Cochlear Limited, which has provided implants to more than 250,000 patients over the last 30 years. Blake S. Wilson, a professor at Duke University in Durham, North Carolina, began working full-time on CIs in the 1980s when he developed the continuous interleave sampling system. This method made it possible for CI recipients to understand words and sentences with far greater clarity than before. Wilson's breakthrough laid the groundwork for sound processing strategies used widely in today's CIs and resulted in a rapid expansion in the number of deaf and nearly deaf persons who have received a cochlear implant in one or both ears. More than 320,000 hearing-impaired people have received CIs in one or both ears. This life-improving device was made possible through the groundbreaking work of Blake S. Wilson, Graeme M. Clark, Erwin Hochmair, Ingeborg J. Hochmair-Desoyer, and Michael M. Merzenich. And for this, we award these pioneers the 2015 Fritz J. and Dolores H. Russ Prize.